All right, let's take a look at lesson number 4 in chapter 3, which is titled the product rule. And the product rule is a new derivative rule when we are multiplying two functions together and we want to find a faster way to find the derivative. And generally in this lesson, we ask students to not simplify the multiplied derivatives. It's just easier to just kind of write out the final answer. So this symbol over here, d over dx, means take the derivative of, and then we have our first function f of x, and that's being multiplied with our second function g of x. So they're being multiplied together, and that's why this is called the product rule, right? So the product rule states that if you want to find the derivative of two functions being multiplied together, you take the derivative of the first function, and then you multiply it with the second function, and then you add that to the derivative of the second function times the first function. Now, this is a formula that you don't need to memorize, and this will be given to you. You just have to be able to recognize when to use it. Okay, let's take a look at a few examples here, because once you do a few examples, the product rule isn't too bad. Now, for this particular problem, we have p of x equals to this binomial multiplied with this binomial. So this is a very good indicator where you should be using the product rule because you're multiplying two functions together. Now, let's just say you did not know the product rule. Based out of lesson number 3, you would probably FOIL this out. So let's just see if we can find the derivative of this without using the product rule. So 3x squared times 2x squared will be 6x to the power of 4. And then 3x squared times -1 is going to be negative 3x squared. And then if we multiply the insides, we get positive 4x squared. And then 2 times -1 is -2. If I go ahead and if I simplify this, I got 6x to the 4 plus x squared minus 2. All right, so there's my function there. And if I take the derivative now using the power rule from lesson 3, 6 times 4, or 4 times 6 will be 24x to the power of 3 plus, and then we soccer kick this to the front, so 2x to the power of 1, and the derivative of a constant will be 0, so there's my answer. Okay, so there you go. That's how you would find the derivative of that function by foiling it out and using the power rule there. Okay, let's see if we can find the derivative now using the product rule here. So let me just erase this, and what I'll do now is the product rule states that if you want to take the derivative right away without foiling it, you take the derivative of the first term or the first function, and the derivative of that is going to be 6x. Right, so 3 times 2 is 6, and then we multiply that with the second function, which is 2x squared minus 1. All right, and then we add that to the derivative of the second function, and that's going to be, well, 2 times 2 is 4, so that'll be 4x. And then we multiply that with the first function, which is 3x squared plus 2. Okay, and then after that, this answer right here is totally acceptable. And if you want this answer to look like this answer, you just distribute and collect like terms. So if I did that, 6x times 2x squared will be 12x cubed. And 6x times -1 will be -6x plus, and then 4x times 3x squared will be 12x cubed plus, and then 4x times 2 will be 8x. Okay, and as you can see, if you actually collect like terms, 12x cubed plus 12x cubed is going to be 24x cubed. And if I take -6x plus 8x, that's going to give me the positive 2x, right? So as you can see, the product rule is very good so that you don't need a FOIL. In fact, you can take the derivative right away. Moving on to example B, if I want to find p prime of 1, well, you just insert 1 for all the x's, right? So 1 would go here and 1 would go there. So 1 is a very easy number to calculate. So 1 cubed is 1, and 1 times 24 is 24, plus 2 times 1, it will be 2, and that will be 26. Okay, the last question C is find the equation of the tangent line when x equals to 1. Okay, so what you could do is you can go back to the original function here. Let me just kind of erase some of this. Let's go ahead and find p of 1. All right, so that means you literally plug in anytime you see an x, you plug in a 1 there. So if I calculate this, 1 squared will be 1, and 1 times 3 is 3, so 3 plus 2 times, well, if I plug in 1 there, 1 squared is 1, and 1 times 2 is 2, and 2 minus 1 is 1. So if I multiply that out, I get 3 plus 2, which is 6, and 6 times 1 will be 6. Oh, sorry. 3 plus 2 is 5, and 5 times 1 is 5. Okay, so what does that mean? What that means is when x is 1, the y value is 5. And this right here is my slope. So if I go ahead and write out my equation of the tangent line here, we'll see this many, many times. The pre-calc stuff is finding the y value, and you're given the x value. And the calculus stuff is finding the derivative value there. So if I had to use my correct points here, I get y minus 1 would equal to 26 bracket x. Sorry, I made a mistake again. Y minus 5 equals to 26 onto x minus 1. And there you go. That right there is the equation of my tangent line. Okay, let's see if we can do a few more product rule questions here. So use the product rule to find the derivative of this. Now, when you find the derivative of that, let's just say this is y equals. So I would write this in a way where it's in ready form. And it's not in ready form just yet because you have this square root of x. And I would change that to x to the power 1/2. All right, now this is in ready form because everything is in terms of a power. And as you can see, now you have two functions being multiplied with each other. So this is a good opportunity to use the product rule. So y prime. All right, so derivative of the first function, and 4 times 2 is going to be 8, so 8x. Close that bracket off, and then we leave the second term alone. And then we add that to, well, what's the derivative of the second term? Well, there's a 1/2 here, right? So the 1/2 goes in front, the x remains, and then you subtract 1 from the power. So that's the same thing as minusing 2 over 2. So 1 minus 2 will be negative 1 over 2. And then we multiply this by the first term, which is 4x squared minus 5. Now this is a correct answer here, but if you want, you can change all the powers back into radicals. So anytime you have a power 1/2, that's the same thing as the square root, right? So that'll be the square root of x plus. Okay, now you have this part here with the negative power there. So that's going to go on the denominator as root x. And then this 1 will go there, and that 2 will go there. So if I use a few colors here, this 1 is that 1 there, and this 2 will be that 2 right there. And then we have this times 4x squared minus 5. And there you go. There's a better answer for that particular problem. Usually in chapter 3, students are definitely allowed to write their answer in this form here, and that's also full marks. Okay, for the next example, we have a differentiable function, and I want to find an expression for the derivative of this. So once again, I have a function x cubed, and I'm multiplying that with f of x. So this is nice because this is a product of two functions. It's a product because we're multiplying two functions, sorry. So let's take the derivative of the first term. The derivative of x cubed is 3x squared times the second function, which is f of x, plus the derivative of the second function. Now I like this one because this one's easy because the derivative of f of x is just f prime of x. And then the first function is x cubed. And there you go, there's the derivative of that particular problem. Okay, let's take a look at this last question here. There's a lot going on. Usually what I do is in class, I tell the students to focus on the later half of this question. And our goal is to find f prime of 2. And we're given all of this, right? All that green stuff. The green stuff doesn't really matter. What you need to do is you need to focus on the yellow part first. So if you focus on the yellow part, I have f of x equals to g of x times h of x. So that's my function right there, right? So that's a product. And we're going to find the derivative here. So this will be f prime of x And what's the derivative of the first function? Well, that's going to be g prime of x times the second function, which is h of x, plus, now we need the derivative of the second guy, which is h prime of x, and then we multiply by the first function, which is g of x. All right, so there you go. There is my my derivative expression, and then we need to find f prime of 2. So f prime of 2. So what that really means is that anytime you have an x, that changes to a 2, right? So all these x's now change to 2's, right? So this will be equal to g prime of 2 times h of 2 plus h prime of 2 times g of 2. And now you use the green material, or the information highlighted in green, to substitute here. So what's g prime of 2? Well, g prime of 2 is going to be 1. What's h of 2? h of 2 is going to be 3. What's h prime of 2? h prime of 2 is right there, which is 5. And finally, g of 2 is the second one here, which is -1. And then you just kind of multiply that out, and hopefully we got this. This will be 3 minus 5, which equals to -2. Okay, so that should definitely conclude the video for Chapter 3, lesson number 4. It's a quick one there, so the product rule doesn't take too much time. What we did next was we kind of started looking at Chapter 5 here, lesson number 5, called the quotient rule. And quotient is pretty much the opposite of the product rule. It's when you're dividing two functions. So there is another rule when you're dividing two functions, and there's a derivative for that called the quotient rule. So if I take a look at the rule right here, d over dx means you take the derivative of this fraction right here. And if I read the rules correctly, it states that you take the derivative of the top function and you multiply it by the bottom function. So sometimes I kind of write things like this is the top function, derivative of the top, times just the bottom, times the top, times the derivative of the bottom. And then you divide by the bottom squared. Okay, so obviously g of x is the bottom right of your fraction, right? And f of x is the top part of your function, right? So basically the proper terms would be numerator and denominator, but I'll just use top and bottom. So once again, you don't need to memorize this function, but if you're dividing two functions here, f of x divided by g of x, you're taking the derivative of the top times the bottom minus the top times the derivative of the bottom divided by the bottom squared. Okay, so if I take a look at this function q of x, we don't actually do this particular problem, but this is a quotient of two functions. And if you actually applied the definition of the derivative right here and went through all these algebra steps, you would get to a final answer down here. And what we're trying to say in this particular chapter is that we don't have to use the definition of derivative all the time. In fact, we really don't want to. We want to have other rules where we can find the derivative a little bit faster. So the next rule that we're going to learn in this chapter is called the quotient rule. Okay, so what we're going to do for our very first example is we're going to take a look at this problem again, and we're going to apply the quotient rule to it and see if we get this answer down there. And hopefully you'll be convinced that the quotient rule does indeed work, and you don't have to apply the definition of derivative to these problems all the time. Okay, so let's take a look at, actually, hold on, I didn't realize I had some of this already filled in here, so I'm just going to erase all this and then we'll redo it. Erase all that too, okay. Sorry, I should have had all this erased before I started this example, but sometimes you just can't prepare for it. Okay, let's go back to that first example here. Okay, so we're going to redo that first example, and here is our rational function, and I want to find the derivative. So what I'll do first is I will highlight the top, and I will highlight the bottom. So I'll say that this is the top, and this is the bottom. Okay, let's do the quotient rule then. Q prime of x. As soon as I write that prime symbol there, that means I'm trying to take the derivative. So the first step of the quotient rule is you take the derivative of the top, which is x plus 1. So what's the derivative of x plus 1? Well, that's going to be 1. And then you multiply that with the bottom, which is x squared plus 1. And then you subtract that from, the top times the derivative of the bottom, which is going to be 2x, right? So the derivative of the bottom is 2x. Now, you can interchange these, right? So it doesn't really matter if you take the derivative first of the bottom and then times by the top, or you can do what I did, which was top times the derivative of the bottom. So when you're multiplying, the order doesn't matter. And then after that, you would all divide this by the bottom, which is x squared plus 1, and you raise it to the power of 2. That satisfies the definition. Now, this is totally correct for full marks. If you wanted to simplify this by distributing, you would get x squared plus 1. And then if you distribute, all of this with that, let's do this very slowly here. 2x times negative x is going to be negative 2x squared. And then if I multiply just the 2x with this negative sign and that positive 1, if I multiply that together, so 2x times 1 is going to be 2x, and then 2x times this negative sign will be negative 2x. And then if I divide that by the bottom squared here. And if we go ahead and simplify this, I see an x squared and a negative 2x squared. So x squared minus 2x squared will be negative x squared. Those cancel off. Minus the 2x and then the positive 1. All divided by the bottom squared. All right, so if you take a look at this answer here, and if you compare it back to this answer here, you'll notice that it's the same answer, right? So you can be assured that the quotient rule is a much faster way to find the derivative instead of using the definition of the derivative, right? So make sure you do know the quotient rule and how to apply it. It's a very effective way of finding the derivative of of rational functions and where you're dividing two functions. Next question is find the x coordinates where q of x has a horizontal tangent line. Okay, when you have a horizontal tangent line, that literally means that your slope is equal to 0. Right? So we definitely found our derivative as being negative x squared minus 2x plus 1 all divided by x squared plus 1 all squared. We found that from the previous question. And what we're going to do now is, because we want a horizontal tangent line, the derivative expression must equal to 0, right? We want to find the x values such that our function will give us a slope of 0. Now, this is really important. When you have a fraction equaling to 0, what you want to do is, remember, this is kind of like some of the investigations that we did. If you get 0 out of 10, that's 0. If you get 0 out of 100, that's 0. If you get 0 over infinity, that's 0. What really matters when your fraction equals to 0 is that you want to make sure that it's the top part of the fraction that equals to 0, right? It's this top part that equals to 0. So, in fact, the bottom really doesn't matter. And all you have to do now is solve this quadratic by using the quadratic formula. So I know that my a value is -1, my b value is -2, and my c value is going to be 1. And if I use my quadratic formula of negative b plus or minus the square root of b squared minus 4ac divided by 2a, I can apply the quadratic formula to solve this particular value. The good news is I just want to find the x coordinates for this particular case. All right, so let's go ahead and do this. X equals 2. Well, I have a -2 here, so that's going to be 2 plus or minus the square root of b squared, which is going to be -2 squared minus 4 times a times c, all divided by 2 times a, which is -1. Okay, and if we go ahead and simplify this, it'll be 2 plus or minus the square root of -2 squared is going to be 4. And then I have a minus sign and a minus sign, so that's going to be plus. 4 plus 4 is going to be 8, all divided by -2. And we can finish this off by just writing this as 2 plus or minus the square root of 8 divided by -2. This is totally fine for a final answer in my class. If you want to go ahead and keep on simplifying this, this would be 2 plus or minus 2 root 2, all divided by negative 2. And then if you work out your answers here, one answer will be 2 plus 2 root 2, all over negative 2. And the other answer would be 2 minus 2 root 2, divided by negative 2. A lot of work here. And finally, this would be negative 1 minus root 2. And this would be negative 1 plus root 2. So those are the answers that you get here for the x-coordinates. Okay, that's it for this homework help video.